I'm going to do a layout sketch for the Thrifty elevator. So I'm going to go to the web browser here. This is what the Thrifty elevator looks like. And you can get a one stage, this one, or a two stage, where it's got this inner extending frame plus the carriage, off of their website. But you can't get a three stage off of their website, and that's much more complicated and frankly much more interesting. So the nice thing about the Thrifty elevator is that unlike the Andy Mark, one, the distance between these tubes, so like left-right distance here, is a ½ inch according to their guide, and the distance between the tubes at the bottom when it's fully collapsed is 0. The tubes just stack directly on top of each other. So that makes this much simpler than the Andy Mark elevator, where you have a bunch of things going on. But we still will have some complexity here when we get to it, because obviously this sprocket here with this chain would interfere with another stage going up. So we'll cross that bridge in a moment. But first step is come back to SolidWorks. We'll make a new part, and let's sketch on the front plane. So basically what I want to do is let's put a center rectangle here, and this represents the bottom tube. I'm going to put, oh, come on. I'm going to put this vertical from there, and I'm going to put this bottom line coincident. Now if we go back to this, let's just confirm which way do these tubes go. So this bottom tube should extend out beyond the edges, but at the very least the side tube should come down to meet the bottom tube. So side tubes down to meet the bottom tube. We'll do a corner rectangle up on each side, and let's give these some dimensions just to start with. Let's make this 15 inches and make these 30. Collinear. And also, I'm doing a control-click select here. These are all going to be equal, and they're all going to be 1 inch, because that's the size tubing that you need for this. Okay, so there's a pretty reasonable outer frame. The next step is to sketch this inner frame. So I'll do a cross member at the bottom. Again, it'll be down at this bottom here. I will put a pair of uprights on top of it. All three of these and this will be equal. And I'll select the midpoint here, Control select the origin and make that vertical. So it's going to be centered there. Our distance between stages is 0.5 inches. These lines here should be collinear. And I'm going to start actually by just making this approximately the same height as that. We won't make them collinear because that could cause problems down the line, but I'm going to start by making them approximately the same height. Alright, next frame. Go in here, select midpoint, put that vertical there, make our uprights, and this one will get a top because this is the closed stage. Make all of our tubes equal in size. We'll bring this up again pretty close to the top there. And this distance here, I'm just going to set these equal. We'll come out with a line here. That way, no matter how many stages we make, we only have to set this once equal. Okay. And then finally our carriage. Same idea. Carriage will want to get a height dimension here. Okay, this 15 may be a little bit small. Make that 20. Oh, I did not put that vertical over the origin. That's better. Okay, so now we have to figure out what actually sets the relations of these. And for that, we need to draw some back bars in. So I believe that it will be possible to set these to collinear. I'm going to try that out tentatively, but I think they will need to go above here. The ThriftyBot website should show that first you've got the module up here for the bearing module, and then below it you have the chain mount, and then you have the sprocket, and then you can do the back bar. So how many holes did they go down? We probably can do the same thing here. 1, 2, 3, 4, 5, 6, and then 7 and 8 are the two occupied, and it goes in the top holes of the tube there. So that's ½ inch up from the tube. So you come down half, 1, 2, 3, 2, 3, 4, 5, 6, and it's at the top of the 6 hole, so 6 ½ inches down. Six times 0.5. This is 2 inches tall. So there's the back bar. So that would work if it was a 2-stage. We'll find out how this works if it's a 3-stage. We look at this. We would be able to attach a back bar to here. It would have to be small standoffs so that it would fit. But we could attach another back bar above, as long as we go up above the existing end of this tube. So I think 2 inches above there. This will be 2 inches tall. And this will be coincident or collinear with this. And the mounting pieces in here will not interfere with anything going on here. This bearing module is only going to touch down here, like that. So, okay, so we're kind of there with this, but now we need the extended version. And so, easiest way to do this is going to be copy, paste. Put this bottom collinear. Just set that some distance away. Okay, so it didn't copy our symmetrical bits and everything. That's okay. Select midpoint. Vertical, select midpoint, vertical, midpoint, vertical. This length here will be equal to that length there, and there everything else is set. So what we have to do now is we have to break some of these things apart. So move entities does not work. Uncoincident this. There we go. That's what we need. That's uncoincidented. This needs to be uncoincidented. This point needs to be uncoincidented. Here we go. And then instead of this dimension here, and this being collinear, we're going to make all of these line up by making them equal. So this line is equal to this line. This line is equal to this line, but this stage can now move. This line is equal to this line. Break this collinear. That's equal, that's equal. That's equal. Okay. And then we just do this kind of in reverse. We put this coincident up here, collinear. And then whatever distance there was here is also going to be the distance here, is also going to be the distance here. There we go. So if we uncollineared these for a moment, there's our moving elevator. Okay, I missed one thing. So remember when I sketched this back bar and I put it at the same level as the top of this closed stage that's in here? Well, that's not going to work. I looked back when I was editing the video and I realized that this pulley here, which is going to be on here, has to be above the height of the back bar. So at the very least, the top of the back bar that's on, sort of that middle stage has to be probably level with the bottom of this bar here. I'll show you what that looks like in the layout sketch. So come back here. So right now it's coincident with the top. We have to find out what line is collinear. This is the line that's collinear? Yes. So easy enough. If we put this line collinear, there's going to be a pulley here, and there's going to be a rope clamp on here. And that should work. So we put these collinear. We should be all set. So let's make sure that this updates properly. Let's pull this down. Yeah, that looks like it's going to do it. There we go. Let's talk about how you actually use this as a design tool. I set a couple of dimensions in here which are not actually set in stone. This stuff up here, this is all boilerplate. This has to work this way. Otherwise your elevator stages will collide or you won't have room for a sprocket. That pretty much has to be that way. But we have some flexibility on some of these other dimensions. So first thing I'm going to do, this sliding configuration is nice, but I'm going to turn this into a raised configuration to start with. So I'm just going to make this coincident. So that's when the carriage hits the top. So I put in this 30-inch dimension as an arbitrary height of the outer stage, and I put in this 8-inch dimension as an arbitrary height of the carriage. I don't know why 8 inches is just what I think of for a carriage. But these two are two of the most important controlling dimensions of this elevator. This 20-inch dimension is also a controlling dimension of the elevator, but it is more obvious how that works. So for example, if you have a particular carriage width, you could set that instead. You know, okay, I need to make the carriage this wide. It needs to be 12 inches wide. It's going to expand everything accordingly. But it's less clear what the 8-inch dimension and the 30-inch dimension do. So, this 8-inch dimension, it sets the height of the carriage, but the height of the carriage also sets the overlap distance when everything is fully raised. So if you make this 8-inch dimension larger, the elevator is going to get shorter because it doesn't have as much travel. It's a trade-off. But you'll see that the overlap distance here and here also increased. So that's really important. And it kind of makes sense too, because the overlap distance is your carriage, your carriage distance. So it's effectively like your overlap distance up here as well as in these other places. If you're willing to tolerate a smaller overlap distance, you can get more out of your elevator. You gain a factor for every stage. And this 30-inch dimension here, this was pretty arbitrary. We don't have to define it like this if we're actually designing an elevator that does something in particular. Instead, we can just use this morphing elevator in order to set it. And we can do really funny things, like we can set the distance between the carriage in the raised position and the carriage in the lowered position to some amount. This is the stroke of the elevator. So if that needs to be, like 60 inches or, 80 inches or something like that, you can just set that directly and it'll calculate all of these other internal dimensions. And if you come in here and you say, well, I need more overlap distance for that, well, it makes your elevator taller to compensate, but the bottom of it still ended up in the same spot. So, stuff like that. You may say, oh, I need a particular overall height. That's my maximum that I'm extended, but I need this much travel. So I can only go 92 inches tall. No, I can only go, 87 inches tall. Well, 87 inches tall is getting to the point where you're not going to have any overlap and you're not going to have any carriage height. So it can tell you things like that before you run into those problems. So there you go. That's how this can be a useful tool instead of just a sketch like that.